is Himabindu, Assistant Professor in IARE College. So today in this video, I would like to explain about the concepts of definitions and terminologies in the context-free grammars. So this is the third unit. So what are the main definitions and terminologies in the third unit of context-free grammars? So first coming to the what are the applications of context-free languages? So what is mean by context-free grammars, and we already discussed in the Chomsky hierarchy. So coming to the what is the position of context-free grammars? So here we also have the Chomsky hierarchy. One is the regular language, regular grammar, and next context free grammars, and then it is a subset of context sensitive grammars and recursive enumerable language, recursive or unrestricted grammar, unrestricted grammar. So these are all the four types of grammars in the Chomsky hierarchy. So in this one, we are going to discuss about the context-free grammars. So how we will generate these context-free grammars? Through the context-free languages, we can generate the context-free grammars. So, and what are the applications of context-free languages? So here, these are the languages applications. One is the defining programming languages, so where we are using in a real time. So context-free languages where we are going to use in the real time in the sense, first one is the designing the programming languages. So to design the programming languages, we are going to use this context-free languages. And formalizing the notation of parsing. So here in compiler designing, we need the parsing technique. So in that one, we will use this context-free languages. And translation of programming languages. So here the translation, we can languages we can translate from one language to another language. So in that application, we are going to use this context-free languages. And string processing and processing applications to pattern matching, to check whether the string is in the pattern. So here string processing to derive the string, to derive in some applications the string should be derived. So in that kind of application, these context-free languages are going to be used in the applications. So these are the applications of context-free languages. And coming to the context-free grammar. So in the previous video, we discussed about the regular grammar. So regular grammars, the basic definition here, we have the four tuple. Like that, here also we have the context-free grammars. For that one also, we have the definition with the four tuple. So that four tuple contains V, T, P, and S. So these are the things we are going to use in the context-free grammar. So V is nothing but a finite non-empty set of variables. So non-empty set of variables which are generally represented with the capital letters. And the terminals. So T is nothing but the terminals which are represented with the small letters. And P is the production. So productions are in this form. So A tends to alpha. So alpha, here A is nothing but variable, and alpha tends to, it is a combination of variable and non-variable and terminals. And S is the status symbol. So these are the four things we need to observe in the context-free grammar. So generally, whatever the grammar, either it is context-free or regular grammar or context-sensitive or an unrestricted grammar. So every grammar is having this four tuple notation. Generally the V, S, T, P. So in that one, V is nothing but the non-terminals which are represented with the capital letters, and T is nothing but the terminal symbols, those are represented with the small letters, and P is nothing but a production. So based on the grammar what we are taking, the productions are having some restrictions. So based on the production rules, we can defer the grammars. And S is the start symbol. And define the leftmost derivation. So leftmost derivation and rightmost derivation. So coming to the context-free grammars, we have the two types. So one is the leftmost derivation. So what is meant by leftmost? In the leftmost derivation, so coming to the production rules, we have the grammar. Suppose we'll take one example of context-free grammar, and S tends to A, capital A, and S tends to small a. So these are the production rules of This is an example. So these are the two production rule. So here coming to the leftmost derivation. So here leftmost derivation, in the sense we need to move from left to right direction. So whatever there in the, so we'll take the example of leftmost derivation here. So S tends to capital A. So this is the thing. So here in deriving the strings from left to right, that is nothing but leftmost derivation. So here this is the production rule to derive the string. So to derive the string, when we take the leftmost derivation, so what is the leftmost symbol is there. So we need to substitute this value. So we need to substitute this string with S tends to, here A is substituted with the small letter A and capital A. So this is the leftmost derivation is going to be part. After this, how many values are non-terminals are there? We are going to move from left to right direction. So that is nothing but the leftmost derivation. And like that, we also have the rightmost derivation. The same example, S tends to A. So S tends to A is that. So in this one, coming to the rightmost derivation, we will start with the start symbol and we will derive the string leftmost symbol. Sorry, rightmost symbol we are going to replace. That is nothing but S tends to capital A and small a. So this is the right end. From right to left we are going to move. From right to left we are going to move. So this is the rightmost derivation. And what is meant by CFL? Context-free languages. So context CFL, in the sense it is a context-free language. So with this context-free languages only we are going to form the context-free grammars. And what is meant by derivation? So derivation is a sequence of production rules. It is used to get input string. So here this is the derivation. We can say that it is a derivation. So in this one, if you substitute from left to right, so right to left, we'll get the string like this. So after this A replaced, and this is the terminal, non-terminal we are going to replace, so that we got the string. Finally we got the string. So this entire process is named as a derivation. So it is a sequence of, derivation is a sequence of production rules. It is used to get the input string. So this entire process is named as the derivation. And what is meant by define a parse tree? So parse tree is nothing but after derivation we got the sequence of production rules. So we will represent those production rules in the graphical representation. That is nothing but it is a parse tree. So here the parse tree is the graphical representation of symbol. The symbol can be a terminal or non-terminal. The string is derived using the start symbol. The root of the parse tree is the start symbol. So here this is the derivation we will take. For this one we will we will represent the graphical representation of this derivation. So here we will start with the S. So S is the start state. And after that, what is the equation we got? A, capital A, small a and E. And after this one, we'll take the rightmost derivation. A is replaced, and after this, A is replaced. And if you read this, we'll get the value of the string A, triple A. So here left to right, we need to read. So this is the parse tree. We can represent the graphical representation, the derivation in the graphical representation. That is nothing but it is a parse tree. And next, define a substring. So in that one, if we have the string like this, so here A tends to E. So this is the substring, subtree. We can say that it is a subtree. So a subtree is a derivation tree, a partial vertex of the tree. So here this is the partial vertex of the tree together with all the descendant edges. So edges connecting them and their labels. So these are all the sub trees, or we can say that it is a subtree for the past tree. And next one, define the ambiguous grammar. So what is meant by ambiguity? So when we have the same derivation or same trees, we'll say that the grammar is having the ambiguity in the grammar. So with the same grammar, with the one grammar, if you form more than two past trees, we can say that it is ambiguity in the grammar. So grammar is said to be ambiguous if more than one derivations. So more than one derivation tree is there for a sentence, or other words, if more than one sentence is occurring in the tree or derivation, we can say that the grammar is having the ambiguity. And write the three ways so to simplify the context-free grammar. So we can say that it is a minimization step. So minimization steps. So what are the minimization steps for CFG? So CFG, context-free grammar. So we have three steps. One is by removing the useless symbols from the set of productions, and second one is the emptying the productions, and third one is the emptying the unit production. So these are the three steps to perform the minimization of context-free grammar. So by using the by removing the useless symbols, we can decrease the length, or we can decrease the number of production rules from the grammar, so that the derivation is going to be easy. And we can eliminate the empty production. So empty production in the sense we have to, like A tends to epsilon is there in any production rule, we need to eliminate this one. That is nothing but epsilon production removal. And third one is whenever a type of A tends to capital B is there, unit productions are there, we need to remove this unit production also, and this epsilon production and useless symbols. So these are the three steps we need to perform in the minimization of context-free grammars. And list the intermediate forms of source program. Write about the normal forms. So what is meant by normal form? So by reducing the grammar, so previously we said that minimization steps. So in that one, so we are removing the useless symbols and epsilon productions and unit productions. After this one, so we have the minimization step performed. By reducing the grammar, although the grammar gets minimized, but it is not in a standard way. So it is not a standardized. So here after minimization, the grammar is not in a standardized way. So this is because the RHS of the production rules have no specific format. So here, so LHS and RHS are there. So in this one, right hand side, to maintain the standards of every production rule, we are going to use this normal forms. Normalization is to be performed on the grammar, context-free grammars. And here, what is the difference between the sentences and sentential forms? So sentences are nothing but after derivation, the string is the terminal symbol only. So here S tends to E triple A. Previously we saw this example. So this is the sentence. So this is the sentence. And coming to the sentential form, so S tends to A is there and capital A is there. So this is the combination of both the terminals and non-terminals combination. This type of production rules are named as a sentential forms, and is a string containing the mix of variables and terminal symbols, or all variables, or also all variables. S tends to A like this. This kind of production rules are also sentential forms. So this is an intermediate form in doing the derivation. So here while doing the derivation, we can eliminate this capital A and we'll replace the substitution of this capital A. So while deriving that string, what are the things what we got in the derivation, those are all named as a sentential forms. And define Chomsky normal form. So Chomsky, we have the two types of normal form. One is the Chomsky normal form and Grayback normal form. So we just told that the normalization should be performed. Why? Because to maintain the right hand side, we need to maintain the grammar should be in a standardized way. To produce the rules, to maintain the rules in the right hand side, we are going to use these normal forms. And in that one, we have a Chomsky normal form and Grayback normal form. So this is Chomsky CNF normal form, which is having the rules like S tends to capital A, is all the two values should be in the non-terminals or single E. So these are the things we need to follow for the CNF. So CNF, after converting the grammar, after minimization, we need to maintain the CNF form, Chomsky normal form, in a one standardized way. So we need to maintain the right hand side of the every production rule should be in this either of these two options, two rules, so that we can say that by seeing this one, we can say that it is a CNF, Chomsky normal form. And next, so CFL. So what is meant by Chomsky normal form? We discussed, and also we'll discuss GNF also. Second one is the GNF. So this is also having the rules like, so S tends to terminal A followed by not only exactly A, so the terminal followed by n number of non-terminals. So n number of non-terminals. So A, B, C and so on. And also S tends to terminal. So these are the two rules we need to observe for the GNF, Grayback normal form. And coming to the pumping lemma of the CFL. Previously, we discussed about the pumping lemma of the regular languages. There we divided the string into three parts, and now we will divide this context-free languages in the five values. So that is nothing but U, V, W, X, Y, Z, X, Y. And we have the conditions, the three conditions we need. So same. Like that, and here we need to observe, so Vx, which is greater than or equal to 1, and Vwx is less than or equal to n, and the third one I greater than or equal to 0, and here we need to pump the length of V and X values. Then we will finally, the contradiction is happened. So when we contradiction is there, we assumed what we have assumed is the wrong, and we can say that it is not a context-free languages. List the types of normal forms. We have two normal forms. One is the Grayback normal form and Chomsky normal form. And what are the properties of context-free languages? We have some properties for the context-free languages. What are closed under, how many operations we can perform on the context-free languages. So are closed under union, like two context-free grammars, languages, union, are closed under the context-free language, union operation and concatenation operation and clean closure. So, and for fourth one is under the intersection. So intersection and complement, like CFL complement, like this. So these are the five properties which are closed under the operations like union, concatenation, intersection, clean closure and complement. And what is meant by syntax tree? So define a syntax tree. So it is a concrete syntax tree is an ordered rooted tree. So here if you observe the parse tree, it is a rooted tree like with the start symbol, and we will have the equations like A, like this one. And here in this one, we will derive the string like A to read like this. So this is also a syntax tree. So we strings according to some context-free grammars. And list the applications of CFG. So previously we saw the languages, context-free language applications. Here also for defining the programming languages and parsing the program by constructing the syntax tree and transition of program languages and describing the arithmetic expressions and construction of compilers. So these are all the applications of context-free grammars. And what are the decisions to be considered during the derivation? So to derive the string from one grammar, what are the steps we need to consider? So first decide on non-terminal symbols and non-terminal symbols. See here, if we have the equation like this, to derive this production rule, we need to, the first step is we need to decide the non-terminal which is going to be replaced. So why? Because we have a derivations two types. One is leftmost derivation and rightmost derivation. In this one, based on the derivation what we are taking, we will take one non-terminal value and then we will replace. So first one is decide the non-terminal, and second one is the production rule which the non-terminal will be replaced. So which production rule we are going to take. So that is the second step, decisions we need to take for the derivation of any string. And list the properties of derivation tree properties. So here we have the properties like start symbol. We have to start with the start symbol and derive and read from left to right, and the leaf nodes are always terminal nodes. The interior nodes are always non-terminal nodes. So read from left to right, and these are non-terminal. Leaf nodes are always terminal symbols and intermediates are always non-terminals. So this is about the properties of derivation tree. And next, non-terminal. So what is meant by non-terminal and terminal? So non-terminals which are represented with the capital letters. So which are those symbols which can be replaced. So in the derivation part, those are all the capital letters which we are going to replace with the terminal symbols. So they may also be called simply static symbols, static variables. We can also say that it is a static variable. A formal grammar includes the start symbol and designated member of the set of non-terminals from which all the strings in the language may be resolved by the successive applications of the production rules. So here generally we will write the non-terminals with the capital letters, and with that non-terminals which we are going to replace with the terminal values, then we can derive the string from the equations. And what is meant by terminal? So those are all the leaf nodes, or those are the outputs what we got after the derivation. So which appears in the output of the production rules of formal grammar, and which cannot be changed using the rules of the grammar. So the value of the terminal is not going to be changed in the grammar. So list the different types of derivations. We have leftmost derivation and rightmost derivation. And what is the root vertex? So root vertex is always called as non-terminal. So root vertex is nothing but here is the start symbol. So this is the root vertex. Root vertex, it must be labeled by the start symbol. And derivation define vertex and leaves in the derivation tree. So vertexes and root vertexes differ from the vertex. So here if you observe, this is the tree. So derivation tree in this one. So in this one, this is the root vertex. So root vertex, and these are the vertexes, and these are the leaves. Leaves. So these are the things we need to observe for the derivation tree. So this is the root vertex and vertexes and the leaf nodes or leaves in the derivation tree. List the approaches for representing the derivation tree. So why we go for the derivation tree? Representation. So what are the approaches? So we have the top down approach and the bottom approach. So here top down approach will start with the start symbol. So here we will start with the start symbol and move down from the root node to leaf node using the production rule. So from root node to leaf node we are moving. So this is the top down approach, and we are starting with the root node and ending with the leaf node. And coming to the bottom up approach, we have to start with the leaf node and produces upward to the root. So upward to the root we will until we need to get the string starting symbol. So until we need to reach the start symbol. So what is the partial derivation tree? So partial derivation tree, it is a partial derivation tree is a subtree of a derivation tree. So we can say that it is a partial tree. So this is the derivation tree. In that one, this is the subtree or partial tree. So such that all of its children are the subtrees or none of them are in the subtree. So maybe here this is also a subtree. So these are all the childrens of the vertex. So here this is the subtree or partial tree. We can say that it is a partial derivation tree. So this is about the context free grammar definitions and terminologies. So entirely in this context free grammars we have the most important things is leftmost derivation and rightmost derivation, and we can also convert the rightmost derivation to leftmost derivation. We have some examples we discussed in this conversion from one derivation to another derivation, and what is meant by derivation tree, and so what are the approaches? Top down approach, so top down approach and bottom approach. So these are the important things we need to observe, and what is meant by non-terminals and normal forms. So normal forms are the important thing, and in that one we have the CNF and GNF. CNF and GNF. Chomsky normal form and Grayback normal form. So these are all the important things we need to observe in the context free grammars. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.